Problem number 3. An investment loses 1.75% of its value every week. Find the half-life of this situation. So in finding the half-life, we have in our notes that half-life, we use T to denote half-life. And that is equal to natural log of 2 divided by K, where K is our decay rate. In this case, our decay rate is 1.75%. Well, if we write that as a decimal, then K is equal to 0.0175. So here, in order to determine half-life, the only thing we need is K, our decay rate. Now, what exactly is the half-life? The half-life is how much time does it take to only have half the amount that we started with initially. So for example, suppose you had $1,000 to invest. We want to know how long does it take to only have $500 remaining. Or suppose you have $200 to invest. How long does it take to only have $100 remaining? Notice here we don't have an initial amount, but we can still determine the half-life because the half-life only depends on the decay rate. So here we have T equal to natural log of 2 divided by K, which is going to be 0.0175. And then using our calculator to get a decimal approximation, we have 39.6 rounded to 1 decimal place. So in context of the problem, this would be 39.6 weeks is the half-life. It's how long it takes for the initial amount to be reduced to half. Alright, in problem 4, the half-life T for a particular radioactive element is 1600 years. Find the decay rate K of the element. So here is our formula here for finding decay rate K. It's equal to natural log of 2 divided by T, where T is the half-life. So we have K is equal to natural log of 2 divided by 1600, since 1600 is the half-life. Now getting a decimal approximation by putting this in our calculator, this comes out to be a really small number. It is 0.000433 is the decay rate.